Okay, so this video is for today's UIL computer science meeting. And again, we're going to be looking at some real problems that you might see, or types of problems that you might see within the programming computer science portion of the test. I do want to get to some written topics very, very soon. For right now, it's easiest for me just to do some of these programming portions as far as making the videos go. Because for the other stuff, I'm going to have to prepare some things. But we have until like March 30th for district. So we have lots of time. Yeah, so they are still deciding whether it's going to be in person or if it's going to be virtual. At this point, it's a little better than 50-50 that it's going to be in person, but it's still completely up in the air. All we know is that Chisholm Trail will host it. Now, what that means is probably if it's virtual, I'll be hosting the virtual coding portion. But if it's not virtual, then I'll be hosting the in person, and yeah, that's it. So for those people that are hoping that it will be virtual, I say just hold on and continue to attend the UIL meetings, or not attend, but view them, hopefully it goes one way or the other. It will, but whatever way you're hoping for it to go. So let's look at a problem from 2012, and I didn't have anything prepared today, but I wanted to just pull up the newest one that was available to us, and this one's called Alpha Fun, and the very first one of District 1 Programming 2012, and we're going to see if we can attempt this. Now, what this one wants is for you to sort the words, okay? Now, they don't have any runtime associated with this sort, so you can use any sort that you want. And so what we're going to do is first we're going to create this input file, and we're going to create the program that will read this, and then we're going to sort it based on alphabetical order. Okay, now the alphabetical order is slightly different than what they want you to sort them in, but I'm going to show you our alphabetical order sort so that you can get an idea of how we might go about sorting in the method that they want. Okay, so let's go ahead and do that. So the first thing we need to do is create that file. And so I'm just going to go to File, New, and I'm going to go and, what is this? Get rid of this, don't save. I'm just going to go ahead and get this input file right here. Copy. And I need to make sure that there are no spaces at the end. Okay, perfect. All right, so here is our input file, and we are going to go ahead and save this as alpha sort, I think, alpha fun, and it is going to be lowercase, alphafun.dat. Okay, so, and where are we saving this to? This will be SAT app. I don't see our UIL from last time. Here it goes. We'll just use that as our template. Okay, so we're going to go ahead and save as, and I'm going to go to my Windows, Users, D. Gatewood, SAT app, and this is going to be Alpha Fun. And then I want to save it as all types because I want to save it as a DAT file. dot add. Okay. Okay, so we have that saved. And what we're going to do is we're going to go ahead and pull up our BlueJ. Now, when you go into the programming part of the exam, you're going to be starting with a blank slate. But once you get that first program done, you can copy and paste this starter code so you can save like a minute each time. All right. So just keep that in mind. So what we want to do is, so we're reading in this file, and this will say alpha fun here, alpha fun, and we are going to not read in the next line because the first thing that we did there, if you recall from last time, is it included a number of how many entries were in that file. But this one, it goes straight, and it says, well, we are just going to go straight to the words, okay? And so here, we're just going to add all those words, okay? And then we are going to get rid of this because we did this last time. This is our Armstrong number stuff. And here we printed out all the Armstrong numbers between 0 and 10,000 or something like that. And so we have our array list of words, and now we want to sort them. Okay, so we're just going to sort them by alphabetical order to begin with. I'm just going to copy this because we need 2 for loops for our naive sort. And naive sort is just basically the easiest sort available. And it may not be the most optimized, definitely may not be the most complex, but it's going to sort them, okay? Now, one thing that I want to do is I don't want this in a list because a list is going to make it a little bit harder to deal with. And so what I'm going to do is I'm going to say string words is equal to list dot to array. Let's see here. Okay, so that is list.toArray. I don't use these methods often, so here, let's say. Now you won't have Java docs available for you, but array list Java, and I'm just going to go to the Java docs, and I want to array. Okay, so it's going to returns an array contain all the elements in this list in proper sequence. The runtime type of the returns an array containing all the elements in this. Okay, so let's just see how we're going to use this. Arrays.asList, and here I think we're going to use arrays dot arrays.toArray. No, that's not going to do it. Cannot be converted to Java. So here we have an object type. I can't get to array to start. There are lots of ways to do the same thing in programming languages, and now this may not be the most optimized, but I don't want to fiddle around with that for too long. Remember, this is a timed test. And so what I want to do is I just want to quickly create an array. So I'm going to do that just using a simple for loop. I'll just use this for loop right here. And I want to initialize my array of words. And I'm going to do that here. I'm going to say string words is equal to new. And then here you're going to put the size of your words. And for that, it's going to be list.size. Okay? And so that creates this array. And what we want to do is fill in these words. And so here we're just going to say words at j is equal to list.get j. All right? And so that creates our little array. Okay, so array is just going to make it slightly easier to deal with. And so now what we want to do is we want to say if so minus okay. So here, what we're going to do is we're going to say if words, this is going to be I plus 1. Here we're going to say if words at I dot compare to words at j is greater than 0. So if words at I dot compared to words at j is greater than 0, that means that words at I lexicographically comes after words at j. Okay? And so what we want to do is we want to flip them. Okay? And so what we're going to do is we're going to create this string called temp, and this is going to be a temporary store place for one of the words as we, flip the words. Okay, swap the words. So this is going to be words at j. We're going to say words at j is equal to words at I, and then we're going to say words at I is equal to temp. Okay, and this is going to go through it, and it's going to sort it, and we are just going to print out that sorted list. Okay, so we're going to say system.out.println. And this is going to be 0. And here we're just going to say system words at j. Okay, so let's print this out, make sure that it prints out correctly. Here, let's just run this, run. Okay, and it does print out properly because if we compare them side by side, this is alphabetical order, and this is not. Okay, so how do we transfer this knowledge to sort it similar to how the test wants you to sort it? Okay, well, that's fairly easy. All this code is basically the same. But then we want to look at this code right here. Okay, so this provides us the basis of what we want to do. Now, is it going to be quite so simple? Well, maybe not, but let's actually see if we can't do this. Okay, so it says that they want to compare the first two letters. The second letter first. Okay. So one way to do that is to create a string that is composed of those letters all together, if that makes sense. Okay, so I think that's the way I'm going to do it. And so I'm going to say string word 1 is equal to, and we want to compose a string of those words. So now here, let's look at the list again. We want the fourth letter. But the fourth letter is the only letter that's really important, okay? So what we want to do is we want to say if words at I dot length is greater than, and let's just read the problem again. So the fourth letter is the only one that matters. Okay. Now the second letter might matter, but they don't tell us that there's not going to be a second letter. They said that, well, if the fourth letter is not there, then it's going to be a space. But the second letter, they say that, well, there's probably going to be a second letter. Okay, so really we're just checking to see if there is a fourth letter. So if length is greater than 3, if word's length is greater than 3, then we want to do this. Else we want to do this. And then here, we're going to do the same thing, but with J. Okay. And here, we're just going to get that up and string word 1. Okay, and so we are just creating the variable here, and we're going to define the variable within this if statement. So if it is greater than 3, well, all we have to do is say word 1 is equal to words at I dot substring 0 to 1 plus. This means that it has all characters there. Okay, this is going to be 3 to 4, and I'm just going to go to the next line here. Oops, I think we can still do that. And this is going to go to the last character. So how do we get to the last character? Well, it is just going to be words at I dot length minus 1. And this is going to be the first character again. Okay, perfect. And then what we want to do is we'll take this, copy, paste. This is going to be words 2. And this is going to be words at J, 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 J. Blue Jay is kind of going crazy because it doesn't like this being moved to the second line, but it works just fine. So what happens when it is less than 3? And that's this else statement. Well, we still take the first. Well, do we want the first? I thought we wanted the second character. So maybe it's the second character, it's not the first. So this is going to be 1 to 2. 1 to 2. Okay. And this is going to be 1 to 2. Now, this one is the first character. Okay, so we take the second character, and then we're going to take a blank space. All right. Sorry that this is going crazy. So it says a space, and then the last character, and then the first character. Okay, so, and then this, it is basically this, and we have a space here. Oops, that's not what I wanted to do. We have a space here. Okay, so now we got our word 1 and our word 2. And so now what we want to do is we don't want to compare these. We want to compare word 1 and then compare it to word 2. And if word 1 dot compare to word 2 is greater than 0, then we want to do this. Okay, that still holds true. Okay, and so let's see if this sorted list is going to print out exactly what UIL expects, and I'm hoping it does. String index out of bounds, and it's saying, where is it saying? Line 51, line 51, oh, it's this thing right here, J. Okay, and then this should also be J. Sorry about that. These problems happen when you copy and paste. And so let's go ahead and see if this runs. It ran without a problem. And we say wallet, and now is this what we expect? So wallet, airy, egg, eggs, broad, bread. And here we have bread, broad. Ah, okay. Oh, yeah. If all of the above characters are the same, then the words used for those letters are sorted alphabetically. Okay? And so that's an important part. Okay, so we would have probably sent it, well, we wouldn't have sent this in. But here, so if it's greater than this, then do this. Else if I'm going to test if they are exactly 0. That means that they are the same, the letters. And then what we're going to do is we are going to compare them alphabetically, okay? And we just want to do not word 1, word 2. What we want to do is if words at I dot compare to words at J I'm sorry, I have to do is greater than 0, okay? And then we just do this again. So all right, so I'm just going to compile that. Hopefully we get a different result this time. A correct result would be nice. Did that change? I don't remember. And we're still getting bread and broad. Our broad and bread when we want bread and broad. So let's if words we never changed this, okay? This makes a difference. So if they're equal, then we do this, okay? Sorry about that. And let's look at this now. All right, so sorted list is this. This is what we were expecting. We solved a somewhat hard one from this section, from this test, okay? So next time, we're just going to go through this list, and we're going to, you know, try and just do all these problems. And I think what I would like to do is probably do one more this week, hopefully. So yeah, that's it. So I'm going to leave it at that. And I will post this video just in a second. And hopefully this was, you know, somewhat useful for you. Being able to sort in any kind of order, especially lexicographically, is super important. Hopefully you learned that part of the test, or that part of the programming that we did. And, you know, even our naive solution, which used two for loops and went through the problem in, you know, the worst possible way, we still came out to the right answer because we're not dealing with a huge list. But now if we were dealing with 100,000 or even 1,000,000 entries, then things could get a little bit time consuming. And it might time out, but the UIL test is never about optimizing a solution. It's about just getting a solution that works. Okay, so if we were in need of optimizing the solution, then we would probably look at something like quicksort or something like that. But that's not the case here. So what we actually used was a sorting method called bubble sort, okay? And it's probably the most naive. It's the simplest way of sorting, but usually the slowest, okay? So we will continue this next time, and have a good day.